Hello, everyone. So today we're going to finish up 4.3. We're going to get through, instead of doing parallel lines like we did yesterday, now we're moving on to perpendicular lines. Okay, so we're on page 106 here in our student journal, and the problems are really similar to what we did yesterday. If you haven't watched that video or you weren't in the meet, make sure you watch yesterday's video. It's a bit easier. But now we're talking about perpendicular lines. Okay, so right here on this image, it has a picture here of some perpendicular lines. Okay, so the little image I drew earlier when we were talking about perpendicular lines. Okay, you sometimes will think about just this straight on 90 degree, but obviously we can rotate that 90-degree angle. We can have any slope for these perpendicular lines. Okay, but the way we know that another line is perpendicular, okay, non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. Okay, so what does that mean? Let's look right here at this one. We can see right there our m, our slope is -2. So if my original slope is -2, it's saying, okay, well then what's the reciprocal? Remember, the reciprocal is basically that fraction but flipped. Okay, well, how do you flip a fraction if it's not a fraction? You turn it into a fraction. You say, okay, it's a whole number, so I'm going to make this -2/1. So then that's going to be -1/2. But it's not just the reciprocal, it's the negative reciprocal. So I'm going to change that to +1/2. Okay? You flip the fraction and you change the sign. That's how you know if something is perpendicular. -2, -2 is going to be perpendicular to +1/2. Those slopes are perpendicular. All right. Good thing I don't count for spelling, because I think some of you are going to have trouble with this, because I've seen some spelling mistakes before. Don't worry about it. As long as I can look at it and it looks like perpendicular, you're fine. All right, so let's get to it. Here's all this stuff. We did all this with parallel lines, so look back at Wednesday's video if you need help with some of that. And then now we're going to do, the work is pretty much the same. I'm going through and I'm trying to find all these different slopes, but now I'm checking, okay, are any of these negative reciprocals to each other, instead of just thinking, okay, are any of these the same slope? Right? So I'm going to look here at number 10. Okay, it's asking which of these lines, if any, are perpendicular to each other. So basically, I just want to find all the slopes. I want to find the slope of A, I want to find the slope of B, and I want to find the slope of C. Okay, we see I've got line A right here, this darker one. Okay, B is this one going this other direction, and C is kind of that lighter one. So it's nice when it's given to us in the graph, because then we can just count. Remember, slope is always that rise over run. So let's start with A. We're going from left to right. So let's count. I'm going up 1, 2, 3, 4, 5, 6. Okay, so up 6, that's +6. And then over 1, 2, +2. 6 divided by 2, I can simplify that to 3. Right, makes sense? 6 over 2 would go to 3 over 1. 3 over 1 would just be 3. Okay, B, that's my line that's going this way. So again, left to right. Okay, I want to think of my rise first. So I'm going down 1, 2 here. Okay, if I go, if my line moves down, then that's negative. Okay, my rise is negative. So that is -2. And then over my run is 1, 2, 3, 4, 5, 6. Okay, so negative 2 over 6, that's negative 1/3. Okay, so right away we see A and B. Those look like negative reciprocals, but let's check really quick. Let's see what C's slope is. Let's see if A and C are both parallel to B. You can have more than one line be, A and C both be perpendicular to B is what I meant. You can have more than one line on your graph be perpendicular to the same line. So let's see what C is. I'm going to use another color because it's starting to look confusing on there. Okay, again, we always go from left to right. So I'm going to count. I'm going to go up 1, 2, 3, 4, 5, and then over 1, 2. This looks like not quite the same as A. If we look, we can kind of see those angles are a little bit different. So 5 halves doesn't simplify, it's just 5 halves. Okay, so if we're thinking about what is perpendicular to each other, okay, if we think about 3, well, we know that that would be 3 over 1, which would go to 1/3 if we use our reciprocal, okay? And then the negative reciprocal would be negative 1/3. 3 and negative 1/3 are negative reciprocals, so we know that line, what do we have? Line A and B are perpendicular to each other. Awesome. So we're going to use a similar process in all these other examples, except now we might have to do a little bit more work to figure out what these slopes actually are. Okay, so let's look at number 11. Again, these are really similar to what we did yesterday. We're just looking, are they perpendicular instead of are they parallel? Okay, so we're going to have to find our little slope formula, that y2 minus y1, everyone's favorite, over x2 minus x1. We're going to have to do that for line A, line B, and line C. Okay, I'm just going to decide this entire column right here is 0.1, and this is 0.2. So this, and this is 0.1. This, and this is 0.2. Okay, so let's plug this in for the first one. I've got y2 minus y1, so y2 is 1, minus y1 is 4, over x2 is 1, minus x1 is negative 2. So I've got 1, I've got 1 minus 4 over 1 plus 2. I end up with negative 3 over positive 3, which I know simplifies to negative 1. All right, that's my first one. Then for B, I've got same thing. Let's start right here. Y2 is 4 minus y1 is 1 over x2 is 4 minus x1 is 2. Okay, 4 minus 1 is 3. 4 minus 2 is 2. So I've got a slope of positive 3 over 2. Okay, last one, C. I'm thinking, okay, y2 is 4 minus y1 is negative 2. x2 is negative 1 minus x1 is 1. So I've got 4 plus 2 over 1 minus 1. Okay, so 4 plus 2 gives me 6. Negative 1 minus 1 gets me negative 2, which is going to simplify down to negative 3. I think that's exactly what we had before. Okay, so looking at all these values, I'm thinking, okay, is anything the negative reciprocal to each other? Okay, I've got 2 3's here, but if these were negative reciprocals, it would be negative 3 over 2, not just negative 3. And nothing's the reciprocal to -1 here because the reciprocal of 1 is 1. So the negative reciprocal of -1 would just be +1. Okay, and these aren't negative reciprocals. These are just both whole numbers. So it looks like none of the lines are perpendicular. All right. Almost there. 2 more. Let's look over here. Let's do number 13. Okay, now we're going to have to do, instead of calculating out the slope using our slope formula, now we're just going to have to manipulate some of these equations into y equals mx plus b format and find what m is, find our slope. So I've got a, b, and c. So for a, this y equals 3/4 x plus 1, I'm in luck. It's already in slope-intercept form. Okay, y equals mx plus b. So I know my m is 3/4. That one's easy enough. Let's look at b. I've got negative. Sometimes that pen doesn't want to work right. I have negative 3y equals 4x minus 3. So I want to get rid of this negative 3, and I want just y on its own to have slope-intercept form. So I am going to divide negative 3 on both sides. So I know that negative 3 cancels. I'm just left with y. Then I'm dividing each of these terms by negative 3. So 4 divided by negative 3, I'm going to get negative 4/3. And then negative 3 divided by negative 3 is positive 1. Okay, so my slope here is negative 4/3. If we're looking, okay, 3/4, 4/3, one is positive, one is negative. That looks like negative reciprocals to me. All right, so let's keep looking. Let's see if C is also perpendicular. Okay, so I've got 4y is equal to negative 3x plus 9. Okay, same thing. I want to get rid of that 4, so I'm going to divide. Okay, these cancel, so I'm just left with y is equal to, okay, negative 3 divided by 4 is negative 3/4 x, and then 9 divided by 4 gets me 9/4. Okay, so this slope is negative 3/4. Now, at first glance, we might look at that and think, oh, that kind of looks like it could fit in and be a negative reciprocal, but it's not quite, right? It's a reciprocal to negative 4/3, but in order to be a negative reciprocal, one of them would have to be positive and one would have to be negative, but they're both the same sign. Okay? Over here, just 3/4, they're different signs, but they're not reciprocals to each other. They're not flipped. So it almost looks like it should fit, but not quite. All right, the only two that are actual negative reciprocals to each other are 3/4 and negative 4/3. Okay, because you flip that 3/4 to 4/3, and then you change the sign so it's negative. Okay, so lines A and B are perpendicular. All right, just one more, and I actually think these types are the easiest. All right, because we're given a point. It's saying write an equation of the line that passes through the given point and is perpendicular to the given line. So we're given a point, and we have to figure out the slope, and it doesn't tell us what type of equation to write. So I'm just going to use point slope form. All right, so easy enough. I'm already given this point. Don't have to change anything about that. And then I'm going to look at this equation in slope-intercept form to find the slope. Okay, so my original slope is 2/3. If it asked me to do parallel, I would just keep it as 2/3. But since it's asking me for a perpendicular line, now I have to first find the reciprocal. I've got to flip it. So now it's going to be 3/2. And since my original is positive, it's got to be -3/2. Okay, negative reciprocal, I'm always flipping that sign. Okay, so point slope form, that's y minus y1 equal to m times x minus x1. So I've got to plug in for this point. I've got to plug in my slope. So y stays the same always, minus the y from my point is equal to -3/2 times x stays the same, minus x1, which is -2. I'm not going to put minus -2. I'm going to say plus 2. Right? If it had told me to put it in slope-intercept form, I would sit there and I would calculate that out, but it just asked for an equation, and this is an equation. Okay? I know this is a lot, just like the parallel lines. Really take advantage, today on Thursday, I still have office hours. If you have a question, you can always email me. Just make sure you understand everything in chapter 4, because we're going to take that test next week on that short week, that Monday and Tuesday. So just make sure you feel confident about all that stuff. And then I will see you guys later.